Hi, welcome to Algebra 1 with Miss Andrea. We're back at it again, doing algebra, and we're in a unit called Describing Data. This is Unit 8, Chapter 8, Module 8. I think in the online book it's called Unit 6, and it's broken up into two parts, Part A and Part B. We just finished Part A. We're now going to start Part B, and this is page 1 in the Part B section. So we're going to start with some key terms and essential questions. And it's still going to be about statistics. So here we go. Association. What is association? It's a connection between two data values. So when two things are connected. Bivariate data is when two variables are related. So height and weight, or how many sales of ice cream you have on a particular day. And you also record the temperature on that day. So you can see if it's a hotter day, are you going to buy more? Is there more ice cream sales? However, if you have just one type of data, such as just ice cream sales or just temperature, then it's univariate data. All right, two-way frequency table. Now, a two-way frequency table means we're going to have some of that bivariate data. And we're going to have a table with that data. So let's say we have red. We're looking for clothing. Red and blue clothing. And then you've got tops and bottoms. So like jeans, bottoms, B-O-T-T-O-M-S. Okay, I can spell. It's not spelling class, it's math class. All right. So if you have a red shirt, it would go in the top section. If you have a red pants, they'd go in the bottom section. Same with blue, okay? And so you'd count up all your clothing that you have and say you have 3 red tops and 4 blue tops. You have 2 red bottoms and 7 blue bottoms, okay? So this is all the clothing you own. You only dress in red and blue. And so this is a two-way frequency table. There's 2 more columns, well, 1 more column and 1 more row here. So these are columns, okay? This column tells you what's happening in this row. This column is red, this column is blue. This one is total. And then these are the rows. So columns go up and down. And a row goes side to side, okay? If you're familiar with Excel or any kind of spreadsheet, then you should be familiar with those already. So total, and then this is also a total. So what you're gonna get is some subtotals here on the side. 3 plus 4 is gonna go here, which is 7. 2 plus 7 is gonna go here, which is 9. 3 plus 2, which is 5, and then 7, 8, 9, 10, 11 will go here, 4 plus 7. Now, what do you think goes right here? Well, this is going to be the grand total. So you're going to add up all your totals. So 7 plus 9 is going to go right here, and that should be the same thing as 11 plus 5. So we should get 16 for both of those. 11 plus 5 and 7 plus 9. And if we got the same thing, then we did our subtotals, these individual totals correct, okay? So this is a two-way frequency table because it puts that data that's related to 2 pieces of information. So there's 3 things that are both red and tops. Now, conditional frequencies. They're the relative frequencies in the body of the table. So conditional frequencies, all these pieces of data are the conditional frequencies, okay? So not the names, red, blue, total, tops, bottoms, but 3, 4, 7, 9, 11, 16, those are all conditional frequencies. Joint frequency. Okay, so joint frequencies is this data right here in the yellow box. Okay, these are called the joint frequencies. So anything that you counted up, all the red tops, all the blue tops, all the blue bottoms, those are the things you actually counted up. Those are joint frequencies. Then we have marginal frequencies, and marginal frequencies are going to be the things that you added up, the things in the margins. So these two subtotals, the totals of the rows and the totals of the columns, those are the marginal frequencies, okay? Then a relative frequency table is when you have, instead of numbers in here, you're going to have percentages. So if you took this number 3 and divided by 16, you would get a percentage or a proportion here. And excuse me, so if you had that percentage here instead of the number 3, it would be a relative frequency table. All right, so scatter plot. Here we have some height and weight bivariate data, and it is put onto this plot all the little pieces of information. Each dot represents one piece of information. So that information relates the height to the weight, and that's why you have two different pieces of information coming together, and where that connects is where that dot is, right? And so this is called a scatter plot because they're just scattered all over the place. They're just kind of random. There's not really any commonality to it. So then the next word in relation to scatter plot is the trend. So does this data seem to trend in a particular direction or not? Well, it does. It seems to kind of be going in an upward fashion, right? So the higher someone's weight is, the higher their height usually is as well. So this data that we have on this scatter plot does have a trend. So if the values of one set of data, such as weight, increases at the same time, the other set of data, the height, increases as well. That is going to be an increasing trend. If they were to both decrease at the same time, that would be considered a decreasing trend. However, if one increased and the other decreased, or sometimes it increased and sometimes it didn't, it'd be all over the place, then there would be no trend. Okay. This, however, has a positive trend. Okay. A best fit line. Now, a best fit line is when you do a formula to figure out what line fits most of the data. So there you go. I just drew a line. I didn't use the formula, but it would look something like that. That line possibly could be the best fit line. You notice there's two other names for it. It could also be called the regression line or the trend line. Remember, it's trending in this direction. And we use this line to predict future data. So if we said, well, if we had someone who was, say this weight is 200. If you had someone who was 250 pounds, how high do you think they could be? What's a possible height? What's the best guess height they could be? And you could plug that into the formula for your best fit line and get an answer. Correlation efficient. So correlation efficient just means how strong the relationship is between certain variables. So if we think back to that scatter plot that we had, the correlation efficients usually are between -1 and 1. And it has to do with, so if it's going in this direction, it's going to be a positive point. Ooh. 0.4, and you're going to have the scatter plots. If it's neutral like this, it's going to be a 0 correlation coefficient. And if it's negative, the correlation coefficient, it's going to look like a negative slope. So 0. Let's say 3. Okay, so the correlation coefficient has to do with the data, the scatter plot, and how closely it relates to the line that it's representing and what direction it's going. All right, so in this half of the unit of statistics, what we're going to focus on are these 8 questions. By the end of the unit, you should be able to answer these. How do I summarize, represent, and interpret data into categories and quantitative variables? Remember what quantitative means? It means something that you're able to count or number. How do I interpret relative frequencies in the context of a two-way frequency table? Like, how do I understand what the table is showing me? What technology is valuable when making statistical models? How do you determine the regression line or the best fit line for a scatter plot of data? Why are linear models used to study many important real-world phenomena? How do I interpret linear models? How do I determine if a linear or exponential regression is more appropriate for a scatter plot? How can I apply what I've learned about statistics to summarize and interpret the data? So there you go. That's what we're going to be studying this half of the unit, and I look forward to seeing you in the next lesson.